Look at this number. Right? Massive, big number, right? But looks messy, difficult to communicate, difficult to comprehend. So this number, if I write it as doesn't it look compact? Yes, that is the magic of standard form or scientific form. Today we will discuss standard form or what is scientific form, and then we'll move on later in one more class on Aggarwal's Exercise 2, which deals with standard forms. You are with Have Fun and Learn, and I'm JP Dutta. Today we are discussing standard forms. Let's get on with the job. Before going into the topic, a gentle reminder. Those who are new to this channel, if you like the video, please subscribe, maybe put it a thumbs up and share. That will be great, means a lot to me. So let us see what standard form is all about. Standard form can be written as a times 10 to the power of n, where the value of a should be greater than equal to 1 but less than 10. Right? In a way, if we put it in words, it means a can have values from 1 to 9 and n should be an integer. Right? Correct? So what does it mean? Let us see. See, that means suppose you got a number like 7, 8, 0, 0, 0, 0, right? Now see, there is no decimal point visible, but there is, that is 0, 0. That means any zeros written after decimal point carries no meaning. You can add any number of zeros after the decimal point, right? So what in a we have to do is, we have to bring this decimal point to this place, right? Now see, which means if I write it in a standard form, the first digit which have only one significant digit, that is 7, then decimal point 8, right? So you have to bring the decimal point here. So how many zeros? 1, 2, 3, 4, 5, 6, 7, right? So into 10 to the power of 7. Meaning thereby, if you multiply 7.8 by 1 followed by 7 zeros, you get this number. Correct? Suppose you got a number 482 followed by 1, 2, 3, 4, 5, 6, 0, right? Now, if you want to convert it to standard form or scientific notation, we have to bring the decimal point here, because there should be one significant figure before the decimal point. So we write 4.82. Now what about the zeros, right? See here the decimal point is somewhere. We have a decimal point, right? That means after the decimal point, you can add any number of zeros, it doesn't make a difference. So now we have to shift the decimal point 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8 we have to bring, right? So we write into 10 to the power of 8. Got it? So this same number is equal to 4.82 into 10 to the power of 8. Clear? Now suppose we have a number like 0.0000056. Right? So the decimal point is here. We have to take this decimal point, shift it to this place here, right? So that means multiplication by how many zeros? 1, 2, 3, 4, 5, 6, 7, right? So we write 5.6 times 10 to the power of 7. Now see, we have changed the values. So we divide this again by 10 to the power of 7, right? Correct? So we get 5.6 into 10 to the power of minus 7. Understood? Now let us try one more. A small value, right? So we want to represent 5, 6, 8, 9 into standard form. So the decimal point is here, right? So we got to shift this decimal point to this, right? So how many places? 1, 2, 3 places, right? So 5.689 times 10 to the power of 3. Why this? Again your question, right? Like 5.689 by 3 zeros, 10 into 10 into 10. You land up with 5,689. The value is not changed, but we have changed it to the power of 10. Correct? So this is what I wanted to tell you about standard form, and which is also known as scientific notation. In the next class, we will solve RS Aggarwal Exercise 2B, where this particular concept is applied, right? So till next class, bye bye.